Welcome to week 3 of the Digital Twin Talks by the National Digital Twin Programme. I'm Simon Evans from Arup, and this series of talks, hosted here on the Digital Twin Hub, are given by experts across industry on digital twin concepts. Each week, there's been fantastic conversation both during and after the session on the Digital Twin Hub, and don't forget on week 5, all of our speakers will be joining us here for a live panel discussion. So last week, in week 2, we heard from Dr. Brian Matthews from the Science and Technology Facilities Council, where he leads the Daphne project team. It was another excellent talk. We shared some of the technical challenges of creating an ecosystem of digital twins and how Daphne, as a platform, can support the national digital twin. This week, we have Dr. Tanguy from Imec in Belgium. Imec are one of the world's leading R&D and innovation hubs in nanoelectronics and digital technologies, with over 4,000 researchers across sectors such as healthcare, industry, mobility and energy. Dr. Tanguy leads Imec's digital twin programme called Buddy. Buddy, short for Built Environment Digital Twin, is an extensible and interoperable platform. In this talk, he'll be introducing Buddy and how it's being applied to the public and private built environments. He'll also be explaining the importance of standards and how IoT, AI and 3D visualization are being combined to improve decision making. So please enjoy the talk, take part in the conversation on the Digital Twin Hub, and share your views using the hashtag Digital Twin Talks.
Okay, Imec's Built Environment Digital Twin. So the project is called Buddy, which stands for, it's short for Built Environment Digital Twin, and it's Imec's digital twin project. In a nutshell, an urban digital twin is a digital replica of a city. Imec focuses mainly on real-time data sets. So it's a decision supporting tool, and we're looking to support better decisions in different domains. And each of these domains can have different time segments, let's say. They can either be in the past for historical data, in the present for everything that is real-time data, and in the future for simulation and what-if scenarios. Okay, so this is where we stand at the moment. So this is the Gartner Hype Cycle for 2019, and you clearly see that for digital government technologies, digital twins of government were really at the beginning of this hype cycle. So that means that there is a lot of buzz about digital twins. Clearly there is something there, but what exactly is the value of digital twins in government is still to be discovered. So this is a lot of the work that we've been doing in the last couple of years, is figuring out what types of applications are valuable to address with digital twins. A second oval you see on this slide is data marketplaces. And this is about the fact that in the future, we will see that there will be a lot of data monitored or produced in cities or in the built environment, but not all of this data will be produced by infrastructure that is owned by governments. A lot of it will be owned privately, either by companies or by citizens. And therefore you need some kind of a marketplace to allow access to this data. So we're really very interested in combining these two trends. Some semantics. First of all, the domain. A domain is a view of reality through a certain data set. So it's actually a way to see reality through a certain number of things that you can measure, like for example water quality, air quality, traffic flows, these kind of things. On the other hand, there is a use case, and a use case is an important concept, because to us at Imec, a digital twin is really valuable in allowing use cases that cross different domains. And so for example, being able to understand how a traffic intervention would impact air quality. So this would be a use case that crosses the domains of traffic and of air quality. On the other hand, a third concept is a solution accelerator, which is a combination of a data source and a modeling component. And so that means something that you measure through a sensor, for example, let's say an air quality sensor for particulate matter, and a modeling component, let's say an algorithm that constructs a heat map out of this particulate matter sensor data. And each of these solution accelerators can deliver value in what we call the YTT domains, so yesterday data, today's data, or tomorrow's data. Right, so what is the promise of built environment digital twins? We said that we're still figuring out what these digital twins can be applied to, what kind of value they can add. So one of the key elements that we've seen is that, they can be used to overcome silos. In cities and the built environment in general, we see many different departments in a city, for example, that each have their own IT systems, their own IoT systems. They are very good at doing what they do in isolation, but it is not yet possible to connect these. So to us, a city, it's an interconnected system. So changes in one part of the city have impacts on other parts of the city. So it's really important to see this system, this city system as a whole, and therefore we need to cross silos and to cross disciplines in terms of decision making. For this, we need to move from the situation that we see to the left-hand side of this slide, so the smart city as it exists today with all of its isolated platforms. And very often it's lack of data strategy. So it's not always clear in terms of data strategy what type of real-time data, for example, you need to gather, because it's not really very clear where the business resides. And we think we need to move to the right-hand side of the slide, so the smart city of tomorrow, where there is more interoperability between different silos, and there is a clearer idea of the type of data strategy to follow, so what to measure, what type of systems to build. For this, of course, you need to add value, and this is something we aim to do by combining IoT technology with AI, artificial intelligence technology and machine learning, and also opening up these silos using open data, contextualized data, and data standardization. We're looking mainly at two domains. The built environment digital twin can be applied to the public built environment, so that's roughly cities, but also to the private built environment. We're seeing many challenges that apply to cities that also apply to private environments, like, for example, big company campuses that also have a big set of buildings to manage. So we're working on these two segments. This is the general technical and business architecture of what we are working on at the moment. So, well, it's not a very detailed technical architecture. For this, we have other figures. But the main takeaways of this drawing or this figure are the fact that there is a top part, which is the body platform, which is composed of a graphical user interface, which you need because it's a decision-making tool. So you need to actually provide the end user a way to make these decisions, but also a semantic broker where different data sources actually come together. And these data sources are what we call solution accelerators. So they are in the bottom part of this figure. A solution accelerator, as I've already said before, is a combination of a sensor type of algorithm and an API to make sure that it can interact with the other parts of the system. To make sure that these the bottom parts can actually talk to the top parts, we need standards. We need to have standardization. So for this, we're working on and together with different entities at a European or international level to make sure we use the most interesting standards to allow this communication between solution accelerators in the system. So it's also important to understand that to us, these solution accelerators can communicate with the top part, so with the platform, but they can also communicate with each other. So for example, it is quite interesting for some air quality models to understand what the real-time traffic situation is like. So that means that if you would have a solution accelerator on air quality modeling, you would be able to have it communicate with a solution accelerator on traffic modeling. And if for some reason you would like to take out the solution accelerator on traffic modeling and plug in, I don't know, another type of solution accelerator, you would be able to do that because your solution accelerators are well standardized. Also, if you're able to communicate with the buddy platform and you're using the right standards, then normally you should be able to also communicate with other digital twin platforms. And as we very often hear, there is this global economy of digital twins that is starting to rise or to emerge. So it would be really interesting if you have a standardized solution accelerator so you can use it in different digital twin platforms. Right, so how do we see the added value of a built environment digital twin if you compare it with other existing geospatial systems, for example? Well, the fact that it is extensible, as I've already said, we want to be able to plug in solution accelerators that actually cover different domains, because every built environment, every city, every company campus has a different set of challenges. So therefore, you need to have an extensible digital twin platform. Also, interoperability is key. We see that many cities are investing in their own IoT system, which they buy from big IoT vendors like Microsoft or Amazon. So it's quite important that the built environment digital twin be compatible with these big IoT platforms. And therefore, it of course needs to be standards based. Also, machine learning should be at its core. For the moment, we see a lot of modeling approaches that are really using process-based modeling, which is very powerful, but requires a manual tuning of a number of parameters. With the recent emergence of machine learning and deep learning, we believe it's really important that these algorithms actually learn by themselves and that they get a central stage in a built environment digital twin, so that you have algorithms that actually become more and more accurate in doing predictions over time. And then finally, user experience to us is very important, because if you want to allow decision making over different domains, then you should not presuppose too much domain knowledge. You should not have people read the 200-page manual before they are able to understand the impact of decisions in different domains. And to allow that, you really need to have a very good user experience. So for now, there have been a number of domains on which we have worked, in which Imec also has a number of competences itself. But in which we also work with many partners to allow the best solution accelerators to be built. Domains that we've worked on are water quality. We have a new water quality selective ion sensor for measuring things like, for example, salinity in water. Air quality, people flows. So where do people actually move to in cities? There's a lot of data about where they move to when they are motorized, but much less so when they are not motorized. Flooding risks, which part of a city may be flooding in the near future. quite important in the context of climate change and flash floods. Traffic situation, the status of emergency vehicles, and then more for the private segment, room occupancy. So where are people in different parts of the campus, which is important for evacuations, for example, and also energy monitoring and the impact of certain interventions on energy usage. Just to wrap up, a couple of the most recent screenshots from our development pipeline. This is a view of city flows. So where do people move to in a non-motorized way in the city of Antwerp? And this is about air quality, NO2 pollutants in the city of Antwerp. This is a screen, a graphical user interface render of what would happen if you would close a road in Antwerp. What would be the impact on air quality? And just as a final slide, I want to draw your attention to a European Horizon 2020 project called DUIT, which we are doing, where we will be looking at deploying digital twins first in Pilsen in Czechia, and then in Athens, and finally in the region of Flanders in Belgium. So if you're interested, either drop me a mail or visit the page at imeccityofthings.be for more information on the Digital Twin project. And if you want to know more about the DUIT project, you can go to www.digitalurbantwins.com.